Hey guys, welcome to this video.
Anti-math.
So we're going to do related rates. So this one right here. And we have 21 problems. There's some notes here with steps and a sample layout, and I'll go over this layout. And common formulas. All this stuff is on andymath.com, and some answers. I'm going to make a video on all 21 of these. They say video, but that button doesn't work right now until I make this video that I'm making right now. And if you have any additional questions, there'll be a button on the top to request additional problems. But hopefully these will all be pretty solid samples to go over. And then I'll use this method, this general guidelines that are listed here. You can read through this if you want, but this is the process I'm going to use going over these 21 problems. So let's get started. So the first one, y equals x squared, dx dt equals 5. Find dy dt when x equals 2. First thing we want to do is take the derivative of this equation they gave us right here. So it's going to be dy dt equals 2x dx dt. So we're going to be using this formula. They tell us dx dt is 5. So I can plug in a 5 for that. Then they say find dy dt. So this is our variable. This is what we're solving for, the dy dt. Just bring down the 2. And then the x, they say, is 2. So 2 times 2 is 4 times 5 is 20. So we get dy dt equals 20. And that is the answer to this one. So that's for this problem. A more general formula for dy dt for this, since dx dt is always 5, it would always be 2 times x times 5. So dy dt will just be 10x. And then obviously when x is 2, dy dt was 20. But this is specifically what I was asking for. And this is dy dt in terms of x. Let's do number 2. Same idea, y equals the cube root of x. They give us dx dt and they want us to find dy dt when x equals something. Same steps. First, differentiate with respect to t. And then this is, we'll rewrite this, x to the 1/3. So we're going to bring down the 1/3, subtract 1 from it to get negative 2/3. And then we still have a dx dt. Now once again, we're solving for dy dt. And then dx dt we know is 6. And then the 1/3 is still here. And then specifically we're solving for when x equals 1. So we can just plug in a 1 for the x. 1 to any power is going to be 1. This is just 1/3 times 1 times 6. 1/3 times 6 is 2. And that's the answer to the question. Let's do the next one. Same idea again. They give us an equation, give us a dx dt, and they want us to find dy dt. Now when we differentiate this one, we have to do product rule. So it's going to be x and then the derivative of y plus the derivative of x times the y, and the derivative of 8 is 0 because 8 is a constant. So this is our new formula that we're solving for here. The dx dt we know is 6. This is what we're solving for. This is our mystery. It's our variable. Then x, they tell us, is going to be 8. And now the second trick with this problem is, how do we find y? Well, we're going to plug in x equals 8 into the original to get y. So when we make this an 8, that means that y would have to be a 1. And now we're solving for dy dt. To speed things up, I'll make this y prime. So we have 8y prime plus, and 6 times 1 is 6 equals 0. Subtract 6 from both sides. We get 8y prime equals negative 6. Divide both sides by 8. And we get y prime equals negative 3/4. Or dy dt. And that's it. Let's see the next one. Now onto the word problems. The radius of a circle is increasing at a rate of 2 inches per minute. What rate is the area of the circle changing when the radius is 10 inches? So first thing we want to identify is the formula that we're going to use. So I see radius, circle, and area. So I'm going to use the area formula for a circle. Area equals pi r squared. Next, we want to have the given. So our given. So what's given is right here. The radius is increasing at a rate of 2 inches per minute. So I'm going to call that r prime equals 2. And that's what they've given me. The next thing I have is the when. Need is the last thing we need. So the need, what rate is the area of the circle changing? So this is a prime is our need. And then when is right here. When the radius is 10. So the when is r equals 10. So first step was identify the formula. Second step was identify the given, the when, and the need. Now the third step is going to be manipulating this formula so we have all these variables. If we just take the derivative, we'll have that. So derivative a prime equals, and then pi is just a constant, 2r r prime. Now we just plug in our given, our when, and our need. So a prime, that's what we're trying to solve for, equals pi times 2. They tell us that the given is r prime is 2, and r is 10 from right here. So 2 times 10 times 2 is 40. So a prime equals 40 pi. Don't forget to label. So we want to label it. So it's 40 pi inches squared per minute. And I just got that from the word problem because we're dealing with inches right here and minutes. And I know the area is squared. And that's that one. Let's do another. A sphere's volume is increasing at 100 cubic meters per hour. How fast is the radius increasing when the radius is 10 meters? First step, find the formula that we're going to end up using. So I see the word sphere and volume, and I see radius. So that formula is going to be sphere and volume, 4/3 pi r cubed, and also has the radius. So that's what we want, 4/3 pi r cubed. Next we have the given, when, and the need. So the given here, the volume is increasing at 100 cubic meters per hour. So our V prime is 100. So the when the radius is 10 meters, when r equals 10. And what do we need? How fast is the radius increasing? We need r prime. So we'll just take the derivative. So we have V prime equals 4/3 is a constant. We're just taking the derivative of this. 4/3 pi is a constant. Pi is a constant, not a variable. And then r cubed, bring the 3 down, r squared times r prime. Now we just plug stuff in. R is 10, so this would be 10 squared. We need r prime, so that's our variable. That's what we're solving for. 3 times 4/3, well, these 3's will cancel, so we have 4 pi. And we know our V prime is 100. Well, 10 squared is also 100, so these guys are going to cancel. So we have 4 pi r prime equals 1. Divide both sides by 4 pi. And we get r prime is equal to 1/4 pi. And the pi is in the denominator. And then last step, don't forget to label. So it's 1/4 pi meters per hour. And it's not meters squared because radius is just measured in meters. And I took meters and hours from here. So that's how I knew how to label it. This is the answer to that one. Let's do the next. The edges of a cube are expanding at a rate of 2 feet per minute. How fast is the volume changing when each edge is 4 feet. So first we need the formula. So I see cube and volume. So the volume of a cube. Volume of a cube is s cubed. So it's v equals s cubed. So then we have the given, when, and need. So the given is the edges are expanding at a rate of 2 feet per minute, and s was our variable for edges. So it's s prime, and it's expanding, so it's positive 2. So the when. So once again, they gave us the word when. So when each edge is 4, so basically when s equals 4. And what do we need? How fast is the volume changing? That's the question. So v prime is what we need. That's a question mark. Let's take the derivative. V prime equals 3s squared s prime. And now just plug in our given and our when. So s prime is 2. S is 4. We're finding when s is 4 times 3. And v prime is what we need. 4 squared is 16. Times 3 is 48. Times 2 is 96. So we know our v prime equals 96. And then we want to label it. Feet and minutes is what we're dealing with. And then volume is feet cubed. So it's going to be 96 feet cubed per minute. And that's the answer to that one. Let's do the next one. A square has sides increasing at a rate of 4 meters per second. At what rate is the area of the square increasing when the area equals 25 meters squared? So same thing, pull out the formula that we need. So we're dealing with squares and areas. So the formula for the area of a square, probably have this memorized, but it is s squared. So area equals s squared. Then we write out the given, when, and the need. So a square has sides increasing at a rate of 4 meters per second. So our given is that the sides are increasing at 4 meters per second. So it's s prime. At what rate is the area of the square increasing? So our need is area increasing. And then when the area is 25, when a equals 25. You just want to be careful about putting in the right variables. So it's not s equals 25, it's a equals 25. So if we differentiate this, we get a prime equals 2s s prime. But notice how one of our things was a. We don't have an a here, so we also need a equals s squared. So we want to find all the formulas. This is the next step. We want to find all the formulas that encompass our variables, known and unknown. So let's fill in everything we do know. This is 4. This is 25. And then this is what we're solving for. And then the 2 we just know. So now notice we don't know the s here, but that's why we needed this equation, because we need this to solve for the s. And when you square root both sides, you get s equals 5. Now we can plug this in here. But if we hadn't brought down this formula because of the given the way it was, we wouldn't have been able to solve it. So it's very important to bring down every formula based on the variables from the previous step, the given, when, and need step. Now we can just multiply 2 times 5 is 10, times 4 is 40, so we have a prime equals 40. And the label for it is meters per second. So it's going to be meters squared per second because of the fact it's area and area squared. And that's that one. Let's do another. A cylindrical tank has a fixed radius of 5 feet. The tank is being filled with water at a rate of 4 cubic feet per minute. How fast is the depth of the water increasing? First, we need the formula. So it's cylindrical. We got radius here, depth of the water. So that's kind of our H, the rate at which it's being filled. So they don't say the word volume, but the fact they're filling the tank, it gets filled with volume for a cylinder. So we want the volume formula for a cylinder. So it's V equals pi r squared H. Now, what's next? Given, when, and need. So our given is that the tank has a fixed radius of 5. So we know that the radius is 5. And we know that the tank is being filled with water at a constant rate of 4 cubic feet per minute. So the volume of that cylinder is increasing by 4. So we'd say V prime equals 4. So those are our givens. Then it says, how fast is the depth of the water increasing? It's a constant. If it's a cylinder and we're filling it with water at a constant rate, it's going to raise at a constant rate. If it were a cone, it's a different story. But the fact it's a cylinder is just going to slowly fill up. So there's no need for a when, because it's always going to be at that rate. So the when there's no need. It's not applicable in this case. And the need is how fast is the depth increasing? Basically H prime is what we're being asked about. So we can solve that. So let's differentiate first. We have V prime is equal to pi is a constant. So we're going to do a product rule going on here. Derivative of the first 2r, r prime times h plus r squared, and derivative of h is h prime. So that's our trickiest derivative so far, but we'll just plug stuff in. It should go smoothly. The need is h prime, so this is the variable we're solving for. R is given to us as 5, so r squared is 25. So this r is 5, and the 2, and our pi. And we know v prime is 4. So that's plugging in everything that we knew. R prime is 0. R is not changing its size. So this right here is 0 for r prime. And then h, we'll just write h because the 0 is going to make it go away anyway. So this whole term has vanished because r prime is 0, because it's a fixed radius. The radius does not change. So we end up with 4 equals pi times 25 h prime, because this first term went away. Now divide both sides by 25 pi, and we get h prime equal to 4 over 25 pi. Don't forget the label. So this is going to be feet and minutes. And the height is not feet squared or feet cubed, it's just feet. So this is our answer. The height is changing at 4 over 25 pi feet per minute. And you can use a calculator to figure out the approximation. But that's it. Let's do the next one. A sphere has a radius increasing at 3 feet per minute. How fast is the volume increasing when the surface area of the sphere is 100 pi square feet? So first step, formula. So it's sphere we're dealing with, and radius, volume, and we also have surface area. So we're going to need both sphere formulas. So here they are, volume and the surface area. 4/3 pi r cubed and 4 pi r squared. So next step, given, when, and need. So the given is that it has a radius increasing at 3 feet per minute. So they're giving us the r prime equals 3. The question is, how fast is the volume increasing? So we need v prime. When the surface area, so A, is equal to 100 pi. So now we want to do formulas that use our given, when, and need. So the next step says manipulate the formulas to get the variables that you have listed with the given, when, and need. So I will differentiate this one, but I will not differentiate this one because I don't have an A prime anywhere, only a V prime. So I'm just going to bring down the second one. A equals 4 pi r squared. But I am going to use it. Now for this one, V prime equals 4/3 pi is a constant, and then 3r squared r prime. Now let's start plugging stuff in. R prime is 3. We don't know r. And then 3 times 4/3 cancels, so then we have 4 pi. And then once we know what r is, we're just going to square it. And then v prime is the thing we're solving for. So now how do we get this r? From the other formula. So I'm going to plug in 100 pi for a, and then we have 4 pi r squared. And now we're going to solve this to get the r to plug back into this formula. Divide both sides by 4 pi, and we get 25 equals r squared. So we know r equals 5. That gets plugged in here. Now we can solve for v prime. 5 squared is 25. Times 4 is 100. Times 3 is 300. So this is 300 pi equals v prime. And so now the answer equals 300 pi, and then we want to give it a label. So this is feet and minutes is what we're dealing with. And then volume is cubed. It's measured in cubic units. So it's feet cubed per minute. And that's the answer to this one. Let's go on to the next. A sphere has a radius increasing at a rate of 6 millimeters per second. How fast is the surface area of the sphere changing when the diameter is 10? So first thing, formula. So we're dealing with the sphere again. We have a radius and we have surface area. And we also have diameter, but that's just basically radius. So we're going to use surface area of a sphere. I don't know if you remember what that was, but it's area equals 4 pi r squared. Now we have given, when, and need. So our given is sphere has a radius increasing at a rate of 6 millimeters per second. So our r prime equals 6. Now the question is, how fast is the surface area changing? So our need is a prime. When the diameter is 10. So well, if the diameter is 10, that means our radius is going to be 5 because the radius is half the diameter. If you wanted to show all the work. Now we use this formula. We're going to take the derivative of it because we have a prime and r prime. A prime equals 4 pi, which is the constant. Then r squared, we get 2r r prime because of chain rule. Now let's start plugging stuff in. A prime is what we want. So we're solving for that. R prime, we're going to plug in 6. R, we're going to plug in 5. And we just bring down the 4, the pi, and the 2. 4 times 2 is 8, times 5 is 40, times 6 is 240. So 240 pi equals a prime. And last step, we want to label it. So we're going to label it as millimeters and seconds. And then since it's area is measured in square units. So it's millimeters squared per second. And that's the answer to the question. Let's go on to the next. A plane is flying above a school. Its altitude is 1 mile. It's fixed altitude. Its speed is 200 miles per hour. At what rate is the distance between the plane and the school changing when the plane is 5 miles from the school? So this is another rule that we haven't really used yet. Step 1 has been when in doubt, sketch it out. We haven't needed to do that yet, but I think this one I'm in doubt enough to have to sketch it out. So we're dealing with a right triangle. The reason we know that is because of altitude. Basically, if you see altitude, chances are you're dealing with a right triangle. So the altitude is 1 mile, so that's fixed. Its speed is 200 miles an hour, so we should give these values. I'm thinking this is going to be Pythagorean theorem, so we'll call this A, B, and C. Include our formula is a squared plus b squared equals c squared, and we have our given, when, and need. We are given its speed is 200 miles an hour, so a prime equals 200. So the need, what do we need? What rate is the distance between the plane and school changing? So this is our school, and this is our plane. At what rate is the distance between them changing? So that's C prime is our question. And then when it's 5 miles away, so C is 5, but it's not constant. But this 1 for B is a constant. So that's actually another given, B equals 1. Cool, so I see some A prime, some C prime, so we're definitely going to need to differentiate our formula, so we can do that. We have 2A, A prime, plus 2B, B prime, equals 2C, C prime. But we're also going to want to use A squared plus B squared equals C squared. This will help us with the missing variable in a minute. So A prime is 200. We still have the 2. And A we don't know, but we do know it because we know B and C, and we just use Pythagorean theorem. So this is when I'm going to use this. C squared is 25. B squared is 1. So now we can solve for a. A squared equals 24. A equals root 24. So that's going to be our a. So we use this formula to solve for a. So this a is root 24 plus, then 2b is 2, b is 1, and b prime is how much is b changing? Well, it's a fixed height. The plane's not changing, so b prime is 0. Equals, and then 2, c we know is 5, and c prime is what we're solving for. So one tricky thing was the b prime is 0. Definitely want to take note of that. When a variable's not changing and you have the v prime, that's always going to be 0. We had another one of those a minute ago too. So this stuff goes away. 2 times 1 times 0 is gone. So now we have 400 root 24, and that can be simplified, but I'll wait, equals, and we have 10 c prime. So now to solve for c prime, we're just going to divide everything by 10. And we get 40 root 24 for c prime. If you had a calculator, you just plug it into your calculator, get the decimal approximation. But if we're going to do exact, we'll need to do a factor tree for 24. I'll just do it right over here real quick. 6 times 4. So the 4 would give us a 2 root 6. So then combine that with the 40, and we have c prime equals 80 root 6. And then we want to give it a label of miles per hour. And that's the exact value, and then you can easily plug it into a calculator to get the decimal approximation. That was fun. So this one had a couple of sneaky things. One is we needed to pull the a squared plus b squared equals c squared to find the missing variable, and the b prime is 0, so don't let that get you. And they didn't really say triangle in here anywhere either, so to know to do the Pythagorean theorem was a little sneaky as well. It's a good one. Good problem. Two planes leave the same point at the same time. One plane flies east at 200 miles per hour. The other plane flies south at 150 miles per hour. At what rate is the distance between the planes increasing 30 minutes after they take off? So this one looks like another Pythagorean theorem, but we'll do a sketch. Two planes, they leave the same point. So this can be our point we start from. One flies east and one flies south. Yeah, we're doing Pythagorean theorem. So we can call this A, this B, and this C. And then we have given, when, and need. So our given, one plane flies east, so the A at 200 miles per hour. So we have A prime equals 200. The other plane flies south at 150. So that would be B prime equals 150. At what rate is the distance between the planes increasing? So we need C prime. So the distance between the two planes is C. So this plane's going this way, this one's going this way. And their distance is getting bigger and bigger as they travel. And we need to know how much 30 minutes after they take off. So the when, it just says 30. So really, another formula we're going to be using here is just distance equals rate times time. But I think we kind of already know that. So I'm just going to say A equals and B equals. And really, we also know C equals. So at 30 minutes after they take off, the plane going 200 miles an hour went 100 miles because it went for half an hour. Then the plane going 150 miles per hour, it went 75 miles because it was also traveling for half an hour at 150 miles an hour. And to get the C, we need Pythagorean theorem. So it's going to be 100 squared plus 75 squared equals C squared. 100 squared is 10,000, and 75 squared is 5625. So that gives us 15,625 equals C squared. So C equals the square root of that, which is 125. You also could have recognized a 3, 4, 5 triangle there, because 75 is 3 times 25, 100 is 4 times 25, so 125 would be 5 times 25. So it's a special 3, 4, 5 triangle. It's okay though. It was fine doing it the long way. Now we have everything we need. So our formula, a squared plus b squared equals c squared. Then when we differentiate it, we get 2a a prime plus 2b, b prime equals 2c, c prime. It's kind of fun. Now plug everything in. A prime is 200. A was 100. And we still have the 2. B is 75. B prime is 150. 2. C was 125. And C prime is what we're solving for. So it doesn't get much clearer than this. 200 times 100 is 20,000 times 2 is 40,000. 2 times 75 is 150 times 150 is, look in the calculator, 2250, 22,500 equals, and 2 times 125 is 250, C prime. So now add these two numbers and we get 62,500 equals 250C. Divide both sides by 250 and you get 250. So C prime is equal to 250, and that is going to be miles per hour. And that's that one. All right, the next one. The volume of a sphere is increasing at a rate of 8 pi inches cubed per second. How fast is the radius of the balloon increasing when the radius equals 2? So first step, we need the formula. So we're doing the volume of a sphere. I see radius, and that's it. So we're just doing the volume of a sphere. The volume of a sphere is 4/3 pi r cubed. Next, we have our given, when, and need. So the volume is increasing, so they're giving us V prime equals 8 pi. Don't forget the pi. How fast is the radius? So the question is, R prime is what we don't know. When the radius is 2, R equals 2. So this should be pretty straightforward. So we'll differentiate our formula. V prime equals 4/3 pi 3r squared r prime. Now just plug in the values. 8 pi for V prime. R prime is what we're trying to solve for. The 3 times the 4/3, the 3's are going to cancel, so it's just 4 pi r squared. And they told us r is 2, so we'll plug that in, 2 squared. So now simplify, we get 8 pi equals 2 squared is 4 times 4 is 16 pi r prime. Then divide both sides by this 16 pi. Pi's cancel and we get 1/2. So the answer is r prime, the radius is increasing at a rate of 1/2, and then to put the label in, inches per second, because radius is measured in inches, not inches cubed or squared. And that's it. That's the answer to that one. Let's do another. 2 cars leave a town at the same time. The first car heads north at a rate of 40 miles per hour, and the second car heads west at a rate of 30 miles per hour. How fast is the distance between the cars increasing after 2 hours? So we did one similar to this already. So we'll sketch it first. So here's the starting point. One's going north, call that A. The other's going west, we'll call that B. And then this one will be C. Okay, so we have our given, when, and need. So the given, the first car heads north, so we know that A prime, that's the first car heading north, its speed is 40 miles per hour. The second car is heading west, so we know the second car's speed is 30 miles per hour. So the question is, how fast is the distance between the cars? So C prime is the distance between the two cars. So here's our cars cruising. So C prime, this is the cars getting further away from each other in this direction. That's what we're solving for. And then the when, increasing after 2 hours. This is our when. So after 2 hours. So this is another one of those where we're going to use D equals R times T to get some of the values. So if A is 40 miles per hour for 2 hours, A equals 80. So we just use distance equals rate times time. If B is 30 for 2 hours, we know B is 60. So those are our wins, these two here. And then we can also solve for C using either Pythagorean theorem or recognizing this is a special triangle. It's a 3, 4, 5 triangle. We have a 60, 80, so C is going to be 100. If you don't understand the 3, 4, 5 shortcut, then it would be 60 squared plus 80 squared equals c squared. 60 squared is 3600. 80 squared is 6400. Add those together, you get 10,000. And square root, and you get 100. But it's just a special case of a 3, 4, 5 triangle. So now we have everything we're going to need. So the formula that we're going to use is Pythagorean theorem. That is a squared plus b squared equals c squared. And then we're going to differentiate it. 2a prime plus 2b b prime equals 2c c prime. Now we plug in values. 2, the a was 80, and a prime was 40, plus 2, b was 60, b prime is 30, equals 2, c was 100, and c prime is what we're solving for. This isn't too bad. 40 times 80 is 3,200, times 2 is 6,400, plus 60 times 30 is 1,800, times 2 is 3,600, equals, and 2 times 100 is 200. C prime. Now add these together, we get 10,000 equals 200 C prime. Divide both sides by 200. And 10,000 divided by 200 is 50. So now our final answer is 50 miles per hour is how far apart the two cars are getting from each other after 2 hours. And that's it. Looks nice. It's elegant, isn't it? I like the sketch with the cars. Our next one. A cylinder with fixed radius 5 meters is filling with fluid at a rate of 50 pi meters cubed per second. How fast is the height increasing? So we already did one very similar to this. We're going to be doing the volume of a cylinder. So the volume of a cylinder was pi r squared h. So for this one, earlier before we treated the radius as a variable, but it's actually a constant. So we didn't do anything wrong, but it could be even easier if we just fix the r as 5. The volume for our formula is going to be pi 5 squared h, 25 pi. I can give an explanation since r is 5 constant. So this is our formula here. Now let's do our given, when, and need. So the given was what we used to simplify this. That is the r is 5. And it's a constant. The when doesn't matter because since it's a cylinder and it's a constant rate of filling up, the height's going to change at a steady rate. So there's no when to include. And the need is h prime. Oh, they're also telling us v prime equals 50 pi. Cool. Now we differentiate. So we have v prime, r, and h prime, so differentiating is probably all we need, and we're going to differentiate our new volume with the r as a constant. V prime equals the 25 pi is the constant, and then we just have h prime. So it's a little bit easier than last time having to do the product rule. Once again, there was nothing wrong with that. This is just easier. Now plug in for v prime, we get 50 pi equals and 25 pi h prime. Divide both sides by 25 pi. And we get h prime is equal to 2. That's going to be meters per second. So that's pretty fast. And that's it. That's the answer to that question. How educational. All right, let's go on to the next one. The sides of an equilateral triangle are increasing at the rate of 10 feet per minute. How fast is the triangle's area increasing when each side of the triangle is 15 inches long? So let's sketch this one out. So it's an equilateral triangle, so all the sides are equal, and we're given that s prime is 10. Our when is going to be when each side is 15, and what we need is the speed at which the area is increasing. Cool. So the formula for the area, its area equals 1/2 base times height. So our base is just one of the s's. That's convenient. But the height is not going to be in S. So this is 1/2 S. This is 60 degrees, and this is 30 degrees. So 30 degrees, that's half of S. So this would be S. So this is going to be root 3 over 2 S. And that's from 30, 60, 90 triangles. If you want, I can show you that breakdown. So here's the 30, which is this top angle right here. This is the 90, which is right here. And then the 60. So our S is right here. And then we know that opposite the 30 is half the hypotenuse. So this is half S. And then we know opposite the 60 is root 3 times the 1/2 S. So it'd be root 3 times 1/2 S, which is just root 3 over 2 S. So the height is root 3 over 2 S. So our formula for the area of an equilateral triangle is 1/2 S times root 3 over 2 S. And we can simplify that into root 3, and then 2 times 2 is 4, and S times S is S squared. And now we just integrate this. A prime is equal to the root 3 over 4 is a constant, then bring down the 2, S, S prime. And then we plug in our values. A prime is what we need. So root 3 over 4, 2, S is 15, and S prime is 10. 10 times 15 is 150, times 2 is 300, divided by 4 is 75. So we have A prime equals 75 root 3. And then we want to give it a label. And I don't know if you caught this. I totally didn't. This says 15 inches right here. But our unit is feet per minute. Instead of 15 inches is 1.25 feet. Because it's 1 foot and 3 inches. So S should be 1.25. I'm glad that we caught this. It's a shame I made the mistake, but this is a way to really hone it in. The good news is it doesn't change a whole lot because none of this depended on that label being correct until we got here when we plugged in the 15. So I'm just going to erase that 15. So I've just erased the S as a 15, and I'm going to make it 1.25. So I could just go back and redo the whole problem, but I kind of like that I messed that up because it's a good way to give a lesson to check that stuff. And I wasn't really wrong because I didn't submit the answer yet. But yeah, just read these very carefully. Hopefully there weren't any more like that. But yeah, the labels are important. That's another good reason to label at the end. Make sure your labels match. That's actually how I caught it when I was just labeling the problem. Bonus points if you caught that before I did. But then I'll erase this 75 root 3. And so now 1.25 times 2 is 2.5 times 10 is 25 over 4. So it's 25 over 4 root 3. And that doesn't simplify. And that is going to be in feet per minute. And that's because I rewrote this 15 inches in terms of feet. And we want to make it feet squared because it's area. So yep, just carefully check your stuff. But it's good. We got it right because I just put the box around it. So that's the answer to the question. Let's go on to the next one. An inverted cone has a radius of 25 inches and depth of 15 inches. If water is flowing out of the vertex of the container at a rate of 5 pi inches cubed per minute, how fast is the depth of the water dropping when the water height is 5 inches? So, sketch for sure. So we have an inverted cone. The radius is 25 inches when the depth is 15. So this right here is 25 and this is 15. If water is flowing out of the vertex of the container at that rate, So as our water level goes down, what ends up happening is we have similar triangles, but they're always going to have a radius to height of 25 to 15. So the radius to the height will always have a ratio of 25 to 15 or 5 to 3, no matter what. So we can cross multiply and get a formula to work with. 3r equals 5h. So that's convenient. I think I have notes for this on the website. Proportional triangles is popular to inverted cones. So it's radius over height equals the new radius and depth of liquid. So that's what we ended up applying for that. So 3r equals 5h. I'll just leave that for now. We might have to isolate one of the variables. So the formula for this is definitely going to be volume of a cone. So the volume of a cone is 1/3 pi r squared h. And unfortunately the r or the h aren't fixed for this one. So we're going to have to do product rule for sure. And then the given, I'll put them over here. The given is v prime, the volume is negative 5 pi. Negative 5 pi. And that's because it's flowing out of the container, so the volume of the container is shrinking. It's not a negative volume, but it's the rate at which it's growing is negative. It's getting smaller. So our when and our need. How fast is the depth of the water dropping? So basically h prime is our question mark. When the water height is 5 inches, when h equals 5. Now we are going to end up using this. Since we're solving using h and h prime, we want to isolate the r so we can substitute it out of this. So we divide both sides by 3. And we get r equals 5/3 h. Now in the place of this r, we're going to plug in 5/3 h. So it's kind of like the one where we replaced it when r was a constant. It's just r is now a function of h, so it does change, but we don't need r in here. We can do it with just h. Now we can simplify this. V equals 5 squared is 25. 3 squared is 9 times the 3 down here is 27 pi, and then h squared times h is h cubed. Now we differentiate. V prime is equal to 25/27 pi is a constant, and then we have 3h squared h prime. So now we just plug stuff in, and I'm going to bring it up here. V prime is negative 5 pi. Now 25 times 27 times this 3. The 3 is going to reduce with the 27 to make it a 9. So we have a 25/9 pi. And then the h we know is 5 squared. And then h prime is what we're solving for. So I just plugged in for stuff in this formula right here. So 5 squared is 25. 25 times 25 is 625 over 9 pi h prime equals negative 5 pi. They'll cancel. Then we'll multiply both sides by 9 over 625 just to get rid of that fraction. And we end up with negative 45 over 625 equals h prime. And that's reducible. You can divide both by 5. So we get h prime equals negative 9 over, and 625 divided by 5 is 125. So the answer is h prime equals negative 9 over 125, and it's going to be inches per minute. And h is a length, so it's just inches. And to double check, there's no weird change of measurements. It's all inches. So we're good to go. Let's tackle the next one. A boat is pulled towards a larger boat by a rope. The rope is attached to the larger boat 10 feet above the rope hook on the smaller boat. The rope is pulled in at a rate of 2 feet per second. How fast is the smaller boat approaching the larger boat when 20 feet of rope is still out. So we've got a little boat, that's a boat, and we got a larger boat. Yeah, I can't draw boats. So then we have a right triangle here. 10 feet is this height right here. If it was 10 feet away, it would be the hypotenuse, but it's 10 feet above. So that's a vertical measurement, and that's fixed. This could be our B, and I'll label this sketch. And then we have our given, when, and need. So the rope is the C here, and it says the rope is being pulled in at a rate of 2 feet per second. So C prime is equal to -2. That rope is getting shorter by 2 feet per second. How fast is the smaller boat approaching the larger boat when 20 feet of rope is still out? So the 20 is C equals 20 is the when. How fast is the smaller boat approaching the larger boat? So our need is B prime. How fast are the boats getting together? So we're definitely going to do Pythagorean theorem here. So our formula is a squared plus b squared equals c squared. But our a is fixed, so to make things a little bit easier, I'm just going to make this 10 squared for a, which is 100, plus b squared equals c squared. Then we are going to differentiate. So the 100 is just going to go away. So it's 2b b prime equals 2c c prime. So now let's plug in values. So 2, then for the b, we're going to have to use Pythagorean theorem for the b. A is 10, so we have 100 plus b squared equals c squared, which is 20 squared, which is 400. We're going to subtract 100 from both sides. We get b squared equals 300. Then we square root both sides, and we get b equals square root of 300. Which we can factor tree it right now. We get 3 times 100. Square root of 100 is 10, so it's 10 root 3. So our b is 10 root 3, which we got by plugging into Pythagorean theorem with some of the values that we were given. B prime is what we need, equals 2. C is 20, and they gave us c prime is -2. So now we just solve. 20 root 3, 2 times 10, b prime equals 2 times 20 is 40 times -2 is -80. Divide both sides by 20 root 3. B prime equals, and that is -4 over root 3. And then we can multiply top and bottom by root 3 to clean it up, because this is our answer. And we have b prime equals -4 root 3 over 3, and it's feet per second. And that's the answer to the question. So there it is, just follow the method. The one thing that was a little out of place was solving for this b using Pythagorean theorem and the stuff we were given. But otherwise, it was just follow the normal flow. And maybe the sketch was a little confusing too, figuring out what the wording is. So a lot of these will just be Pythagorean theorem. Let's do the next. The current, so this is the electricity one. So you might not see this one. The current is decreasing at -2 amps per second as the resistance increases at 15 ohms per second. How fast is the voltage changing when the voltage is 20 volts and the current is 5 amps? They tell us to use V equals IR. V is the volts. R is the resistance, so this is ohms. And the current is measured in amps. So that's just how these break out. So that's our formula, V equals IR. Then our given, when, and need. So the given, the current is decreasing, so the current, which is I prime, equals -2, as the resistance increases at 15 ohms per second. So the resistance, which is R prime, is equal to 15. It's increasing. How fast is the voltage changing? So our need is V prime when the voltage, when V equals 20. And the current, which is I, is the current, is 5, because that's amps. Current and resistance. and volts is the measurement of voltage. That's the easy one. So differentiate V prime equals, and it's going to be I R prime plus I prime R. Just product rule, pretty standard. So let's plug in values. So we need V prime, so we're solving for this one, equals I is 5, R prime is 15, plus I prime is 2, and so we don't know R. So in order to get R, we're going to have to do V equals IR to solve for our missing variable. So the V is 20, the I is 5, so we have to solve for R. Divide both sides by 5, 4 equals R. So now we can plug in 4 for this R. And this I prime was -2. So 5 times 15 is 75. And this is going to be -8 because it's the -2 times the 4. So 75 minus 8 is 67. And that's our V prime. 67. And then the units for V is volts. And our time measurement is seconds. And that's the answer to the question. So if this makes sense, that's it. Hopefully you made it all the way through. Imagine how I feel. Please like this video, please. It's a lot of work. Subscribe to my channel. I got a lot more of these videos. Check out andymath.com. It's got a lot of good stuff for calculus. It's a lot of pages you can go over. Should be helpful. Have a good one. I'll talk to you guys later. Bye.